So here's a combination of absolute value and exponential equation. So we're going to use our absolute value method first, isolating the absolute value. There we are. Now we're going to go and say, well, therefore, e to the x minus 5 equals plus or minus 4. It's really plus or minus brackets e to the x minus 5 equals 4, but we can write it that way around. So we have two answers here. Now, of course, once we have the x in the exponent, we're going to have to go to logarithmic form. There we are, base A, x is the exponent, while a log is the exponent, therefore x equals to the log. In this case, it's base e, so we're going to use ln, and we don't have to put the base in. Remember, that really is log of 9 to base e. And of course, we know if e to the x equals 0, anything to the x equals 0, anything to the x equals 1, then the x must be 0. Here we're going to have to go the other way around. So we're going to go to logarithmic form. We're going to go to exponential form now. And that's where we have to stop. Yes, the memo, if you look at the memo, it goes to a step further where it says 20,1. But this says without using calculator. So therefore, that's our answer. Right, the complex numbers. Determine A and B if that equals that. Well, we're going to take the left-hand side and we're going to write it in that form. And so to be able to do that, we're going to have to take that and then multiply so that we can obtain a difference of squares in the bottom line and get rid of the I on the bottom line. There we are, multiplying out. And we're going to put what I've done here is I've put the real part and the unreal part in two separate terms. Now we're going to equate it to the real and imaginary parts there. So we'll take that. Notice I've converted it from there to a denominator of 26 so that we can compare, because now the blue equals blue and the pink equals pink. We have simultaneous equations. I'm not going to go through the methods of simultaneous equation. In fact, you'll see in the memo, it also just goes straight to the answer. (1.3). So we have to find a quartic, which is a fourth degree equation, with rational coefficients where 2 of the roots are equal to 2 plus I and 1 minus root 3. Well, if they're rational coefficients, we have to have something that gets rid of the I and something that gets rid of the root 3. So therefore, we have to have conjugate pairs. There we are, 2 minus I and 1 plus root 3. So there we are. Remember that if we know that the root is 2 plus I, then the bracket is x minus 2 plus I. And of course, we have x minus 2 minus I, then we have x minus 1 minus root 3, x minus 1 plus root 3. We go to do the little trick of rearranging them. So we put the x and the 2 together, and I separate, root 3 separate, root 3 separate. Now we have a difference of squares and a difference of squares. Multiplying out within the bracket, that's x squared minus 4x plus 4, and minus I squared is plus 1. giving us the plus 5. X squared minus 2x plus 1 minus the 3 gives you minus 2. And we multiply out, and there is our quartic. We could have done it by sum and product of roots, if you want to use that way. So we could say, add those and multiply those, add those and multiply those. So let's do it that way. Sum of roots, that plus that is 4, and that plus that is 2. Product of roots, multiplying together, we end up with 5, difference of squares, and we end up with negative 2. Now, the way it works, remember, is if we're working with a quadratic, it's x squared minus the sum of roots, x plus the product of roots. X squared minus the sum of roots plus the product of roots. So that's negative because the product is negative. And we multiply out and we obtain the same answer.